So good afternoon, everybody. Let's consider this a test as I'm going to do the homework for section 3.1, number 2. I've written the problem up above and wrote out what we are required to find. The forces supported by each of the members and indicate tension or compression. And we'll start this solution by coming up with a few FBDs, and this is point D over there. So looking at the solution, we're going to say that at point D, the FBD has a weight of 200 pounds coming down, and there will be a tension from the cable called TBD. So let me zoom into that. And that's what it will look like. So we're going to use our equilibrium equations. And we know there's no forces in the x direction, so some of the forces in the y are going to be that TBD is positive y. I'm going to put the coordinate system there. And TBD minus the 200 is equal to 0. So that would tell us that TBD is 200 pounds. So right away we found, since it's positive, it's going to be T for tension. I'm going to box that answer like so. That's the first FBD. Let me zoom out. And the other point that we're concerned with in this problem is going to be FBD at D. And over here, let's start the FBD at point B. Okay, so there we're going to kind of draw the same thing, our FBD with our coordinate system, like so. So what's happening at B? You have a 200-pound force going down, and that's from the tension we just figured out. There's going to be a tension force from BC, and there's also going to be a tension force from AB. Okay, now the direction of those are 40 degrees from the horizontal, from the x, and 20 degrees. So there are going to be components to each of those that we'll have to be concerned about. So the first one, we're going to write the sum of the forces. Let's figure this out here. Alright, so the sum of the forces in the x direction are equal to 0. So we have minus TAB cos 40, okay, plus in the positive x direction TBC cos 20 degrees, and those are equal to 0. So there's two unknowns in this problem. Move that over a little. Alright, so you can see the whole thing right now. And now we're going to use the other equation, equilibrium equation, the sum of the forces in the y is equal to 0, which states that, if you can see that now, that might be better. The TAB times sine 40 plus TBC times sine 20 in the positive y minus 200 pounds going in the negative y, and that's equal to 0. So you have right now two equations and two unknowns. So we're going to multiply this is going to be our second equation, and this is our third equation. That would be our first up there. So we're going to multiply our second equation by sine of 40, and multiply equation number 3 by the cosine of 40 and add the results. So when we solve for TBC, we're going to get that TBC is equal to 200 times cos 40 all over cos 20 degrees times sine 40 plus sine 20 cos 40. And this will be equal to 176.9 pounds. And that's going to be tension. And that will be our force TBC. And then since we have TBC now, we can plug that back in to get TAB. And I did all the side work on another sheet of paper to save space. So TAB then is going to be 217.0 pounds, and that's also tension, so all three cables are in tension. So right away we have to kind of verify. We have this first equation up here. We zoom out. We have three actual equilibrium equations, equation 1, equation 2, and 3. So we have two unknowns in the first equilibrium equation and two unknowns in the other. And what I did was solve TBC down here in terms of everything else. So with that said, we can obtain that there is 176.9 pounds in tension for BC, force BC, and force AB, which is also tension, is 217.0.